Good evening, everyone. Am I audible? Please let me know in the chat box. Yes. So let us start this session on APB based GPIO design. Okay. So, with this particular workshop, which we are going to have today and tomorrow, you will get a clear understanding of how you're going to design or how you're going to communicate with your GPIO devices using APB interface. Okay, so the prerequisites of this particular workshop is you need to have an understanding of APB protocol. So, how many of you have understanding of APB protocol? Can I know in the chat box? No need of AHB protocol, just APB protocol understanding we need for this particular workshop. Okay, only one person. Okay. And what about remaining people? Okay. Two, three, four. Okay. So if you're a person who don't know about APB interface at all, so this might be a difficult session to be understood, right? So you can refer to the recordings which are already available on our channel. So APB batch 2 or it will be something like that. The course will be present. So you can refer that. Okay. So that it will be easier to understand this particular APB based GPIO. Like what are we going to do over here? It will be clear. Okay. Yeah. So coming to this particular thing, we are going to have a 2 day workshop as we already know, and we are going to discuss about this APB based GPIO, not about the APB protocol. Okay, so I wanted to make it clear we are not going to discuss about APB protocol here. We are going to discuss the application of our APB protocol, like where are we going to use this. Okay, that is what we are going to do over here. Okay, and you need to also have understanding of Verilog HDL, which is a programming language, hardware description language. You need to know. Okay, so that it will be really helpful in the day two where we are going when we are going to design that. Okay, so if you're also not if you're a person who don't know about Verilog HDL, you can refer to the playlist which is already available on our channel, so that it will be helpful for you to develop this particular code and keep it in your resumes, right? And coming to the certifications, so tomorrow I will be sharing the attendance link in the chat box so that you can fill the form, and only the people who have filled the form will get the certificates. Please note. Okay. Yes. So let us start this particular session with this note. Let me share my screen. Yes, I hope my screen is visible, right? Please let me know in the chat box. Yes, that's great. Okay. So can anyone tell me the full form of GPIO? So have you heard this name anywhere before? GPIO, full form of GPIO. Anyone heard? Anyone knows already about your GPIO? General purpose and yeah, exactly. So it's basically general purpose input output. Okay. Yes. So I think if you're a person who have already worked with your Arduino boards in your graduation or whenever you have worked with, I think you have already seen this particular general purpose input output ports, right? So why are we going to use this general purpose input output port? What is the usage of this GPIOs? Anyone wants to answer? So why are we going to have for any hardware? If you take FPGA also, if you're a VLSI engineer and working with FPGAs, or if you're an embedded engineer where you're going to work on the processor side, like why are you going to use your general purpose input outputs? They are like main peripherals, okay? What is the use of this general purpose input output ports? Okay, I got one answer that they are like main peripherals. Okay, to interact with the external devices. Okay, that's great. So who is going to interact? Processor. Okay, so if your processor wants to, they are used to send or receive the values from or to the SoC, so helps in observability and controllability. Exactly. Yes. Yes, processor or controller, if it wants to communicate with your peripheral devices like your sensors, or your sensors may be anything like your temperature sensor or a humidity sensor. If you're working with Arduino boards, you have seen this, right? So whatever the sensor data which we want to get, that basically those sensors will be connected to our GPA ports so that your controller can access those particular things, right? Am I right? Yes, exactly. Now, so as we have already said and discussed, so GPIO provides communication with the outside world. So a GPIO, which is nothing but general purpose input output, it is for only general purpose, okay, which allows a processor or an SoC to interact with the external hardware devices. Okay, so for example, reading a button or a switch, or else driving an LED, interfacing with sensors, or controlling simple digital signals. So this and all you can have your GPIO ports which can be connected to this, right? Now, so if you see an SoC, so the processor cannot directly connect to the pins. So instead, it communicates through the peripherals like GPIO. Okay. So where the processor is going to be connected to the bus, and bus is going to be connected to the GPIO, and GPIO is going to be connected to the external pins. Now, to understand this particular point, let us take one simple example of one existing board which I have in my system open. Let me share my screen again. Yes. So I have opened a particular hardware. This is basically Zynq FPGA, Zynq Zybo board. So if you have already watched the recordings of FPGA sessions in our on our channel, so you will come to know that we have briefly discussed about this particular board, right? So this is our Zynq Zybo board, and this is our main processor and FPGA embedded into single chip. I will explain what do I mean by this, and these are my push buttons which I'm going to have, and these are my general purpose input output ports which I'm going to have. So whatever the data or whatever the external peripheral devices which I want to connect with this particular board, I'm going to connect it with this GPIO pins. Okay. Now, first of all, let us try to understand this Zynq architecture, not in detail, but let us try to have a brief explanation about this Zynq architecture so that we can come to know what is exactly happening. So coming to this Zynq architecture, actually it's very interesting to note over here is Zynq architecture, this Zynq chip is basically divided into two parts. One is the processor part, and another is your FPGA fabric, which is basically termed as PL, okay, programmable logic. Okay. So this is what our FPGA fabric is. So whatever the code which we are going to write using Verilog or using VHDL, so that particular code will be fabricated onto this PL. Okay, so if you are developing a full adder, or if you are developing a UART, or whatever the code which you are developing using this Verilog or VHDL, that will be converted into your what to say CLBs. CLBs, it will be converted into this FPGA fabric side. So if you want to learn about this particular thing, you can refer to the playlist. There we have discussed a lot about this particular FPGA architecture and all. Right now, so in the Zynq architecture, and if you also want to learn about this Zynq architecture in detail, you can just Google it like Zynq FPGA architecture. You will get the data sheet and clear understandings from AMD. Okay, that will be a really beneficial if you want, if you're targeting to hardware roles also. Okay, yeah. So coming back to our discussion, so if you look into this Zynq schematics or whatever the board you're working with, so generally in this Zybo board, which I have shown you as an example, in the schematics, so we will be having something like GPIO pins. So the GPIO pins will have direct connection with our FPGA fabric only. So let's say these are my GPIO pins. These are my GPIO pins, which will be directly connected to my FPGA fabric. These are not connected directly to your processor, but these are directly connected to your FPGA. The reason behind is your FPGA is very fast, and the processing speed of your FPGA will be higher. Okay, and you can basically read the data directly when if your GPA is directly connected to your FPGA. If it is connected, if these GPIO pins are going to be connected to your processor, then that particular data should be given from the processor to the FPGA side, and FPGA should again or the PL should again what to say, it should configure it or it should compute it, and again it should give to the processor, and from processor we need to give to GPIO. So instead of this particular communication, we are going to have GPIO pins directly connected to our FPGA side or the FPGA fabric side. Okay, so this is the architecture we are going to have over here. Is it clear, guys? How the architecture it is connected? Is it clear? Okay, so let me show you one more time. So in our Zynq architecture, so we are going to have processor and the FPGA fabric which we are going to have. Okay, can anyone tell me why do we use a processor? What is the reason and why do we use a processor? Okay, no one knows why do we use a processor or why do we have a processor? Okay, 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 to compute the tasks. Okay, so let me give you one simple example. So let's say um, this is my application. So this is one software application which I'm going to have, where I'm going to have a graphical user interface, where I'm going to have a small box, and which is going to have some information, and I'm going to have different baud rates over here. Okay, so this is, let's say, some 9600 and 1600, something, some baud rates which we are going to have. Okay, so this is the application and this is my box which I'm going to have, and these are the interfaces which I'm going to have. This is nothing but my graphical user interface, and this is the application which we are developing as a software engineer or as an embedded engineer. They are going to develop this particular application, right? Now, where is this application is going to run? What do you think? Whether it is going to run in processor or whether your FPGA is going to run this? So basically, your applications which are being written in your C, C++, or whatever the language you're going to write it down, right? So these applications will be taken care by your processor. So processor is going to run this particular applications. Okay. So let's say suppose we have our Zynq architecture, right? So here we are going to have the processor over here. Okay. Now this processor is going to run this particular application. Let's say suppose user has selected this 9600. Now the processor will somehow tells our fabric FPGA fabric that user has selected 9600. So whatever the code which we have written inside our FPGA fabric is going to decide 9600 baud rate, and it is going to send the particular data using this GPIO pins. This is how the process is going to run in a lame manner if I want to explain. Is it now clear, guys? So in the Zynq chip, I'm basically taking the example of a Zynq chip where I'm going to have a processor and a FPGA fabric, where if the user selects a particular application, if a user selects a particular option in an application, then particular application will be running inside your processor, and processor somehow tells your FPGA. So what is the method it is going to send? That is not our concern. Okay. So FPGA fabric is the code, is the part where the actual RTL code which you have written will be present. So that particular code will be communicating with your GPIO pins, and it is going to send the UART transaction data or UART receiving data which we are going to send or receive. Is it clear now? And others also, please let me know. Is it clear? Okay, that's great. Okay. Now let us see how this PS and PL are going to communicate with each other. This is my processor. So if my processor wants to communicate with this FPGA fabric or the RTL code which we have written over here, we are going to use a protocol which is known as EXA protocol. So that is why this particular protocol is very, very important over here. So if your processor wants to communicate with your programmable logic or your FPGA fabric, you are going to use this particular protocol which is known as AXA protocol. Okay. So can you tell me the flow, how the processor can communicate with external devices? Yeah, I'm basically trying to establish that flow only. Okay. So if your processor wants to first of all communicate with your programmable logic or the RTL logic, your processor needs to send some commands, right? So that particular commands or whatever the data which we are going to have, that is basically sent by your AXI interface. Using your AXI interface, your processor and FPGA fabric are going to communicate with each other. Okay. Now, coming to my FPGA fabric side. So FPGA fabric has received the data which the processor has sent successfully. Okay. So this is my processor and this is my PL, the FPGA fabric, and I'm going to use AXI interface or AXI protocol where my processor is sending the data to my FPGA side. Now, in the FPGA side, let us say we have developed one RTL code. Let's say we have developed one RTL code which is going to receive this particular data. Okay. And this RTL code which we have developed, right? This should also have AXI interface wrapped over it. Let me show you 1 minute. So this is my processor and this is my PL. So here we are going to have my RTL code. So this RTL code is basically going to send some data to the GPIO pins. Okay, it is going to send some particular data to my GPIO pins. Okay. Now, so this particular RTL is going to receive that particular data. Now, this RTL cannot directly communicate with your GPIO pins. Okay. So here, what do you need is, this is my GPIO pins, and the RTL code which you have developed cannot be directly connected to or cannot directly drive the GPIO data. Okay. So we are going to have something known as GPIO controller. So we are going to have one more particular design which is present, which is nothing but GPIO controller. So this GPIO controller is going to control your pins, GPIO pins. Okay. So I'm not going to care about the connections and how we are going to have over here. Okay. That is not our concern, and how many pins we are going to have. That is not our discussion. Okay. So this RTL code, if it needs to drive any data or if it needs to receive any data from this GPIO pins, this needs to communicate with something known as GPIO controller. Okay. Now, so is it clear up to here? Please let me know how your processor is going to communicate with your RTL code, and RTL code is going to communicate with your GPIO controller, and from GPIO controller to our GPIO pins, right? Now, let me know whether the peripheral devices are directly or any bridge between them. Yeah, it can be any bridge. You're asking about RTL and GPIO controller? Yeah, I will come to that particular point. So let's say, first of all, answer my question. So let's say you are going to have a peripheral, whether that particular peripheral is the processing speed of your peripheral is higher or peripherals are slower speed. So what will be the speed of your peripheral devices? Peripheral devices are generally slower. Okay. So if you have already an idea about protocols, on-chip protocols, we have AHB, EPB, and AXA. AXA is for higher speed devices, and APB is for lower speed devices, right? So here GPIO controller which we are going to have will be basically slower in speed. Okay, this will be slower because it is directly communicating with your GPIO pins, right? So it will be slower. Okay. Now, what particular protocol we need to use for this, for accessing this particular GPIO controller? We are going to use a protocol which is known as APB protocol. So basically your GPIO controller will be communicating using APB protocol, and the RTL code which you have written will be having AXA protocol. So here we can have a bridge between these two devices that will basically convert this AXI interfaces to the APB interfaces, and the RTL code you're going to send, right? That is how you're going to communicate with your GPIO controller. Okay. So again, I'm repeating myself. GPIO controller is going to have APB interface since it is slower. Why it is slower? Because it is communicating with, it is having direct connection with your GPIO pins. And RTL code, if it is going to have AXI interface, since it is directly communicating with your processor, right? Okay. So we will have one bridge Bridge is nothing but it is going to convert this AXI interface signals into APB interface signals for communication between this RTL and the GPIO controller. Is it clear, guys? How we are going to establish the connection? Is it clear? And what about others? Is it clear? So when you're working in the real time, it may be not exactly the architecture which I have shown. It depends upon the designer who is designing this. Okay. Yeah. Now, so coming back to our discussion, so inside a SoC, this and all we have seen. So why GPIO pins need a bus interface? So inside an SoC, peripherals are connected through the buses, and the processor configures the peripherals using the register read or write operations. Okay. So for example, configure pin as input or output, write data to the output pins, read data to the input pins, or enable interrupts. Okay. So what is this? Let us try to understand. So we have a GPIO controller over here, right? So this particular GPIO controller, this is my GPIO controller. This particular GPIO controller is going to have a set of registers inside it. So it is going to have a set of registers. Now, what are these registers? Are nothing but these are basically configuration registers, or you can also say it as configurable registers. So what is this you are going to do is the processor or the RTL code. In our particular case, we have an RTL code in between, right? So when you are going to design this particular RTL code, what you're going to do is from this RTL code, you are going to configure these registers, which are basically present inside this GPIO controller. Okay. So you are, because we are having RTL code, right? So this RTL code is going to try to configure the GPIO controller registers. Now, so this registers can have different functionalities. So the first register we have, right? So it can be a data register. That is, it is just used to store the data which we are giving it from the RTL code. And the second register is basically used to tell whether to perform a write operation. That means from GPIO controller to the output, or whether to perform a read operation from the output to input. So let's say if this register is configured to 0, then it is a read operation. Or if this register is configured to 1, then it is a write operation. From the RTL code, we are going to configure this value so that this GPIO controller will see this register and it is going to perform that particular operation. Okay. And another register may be an interrupt register where depending upon that particular value, a functionality may be designed. Okay. So this is how practically your things are going to work. So we are going to have different registers and each register is going to have a set of address, right? So it is going to have a set of lower address and upper address, which is nothing but my offset. Okay, we will discuss. Anyways, we are going to discuss this and all. So I'm basically giving you a basic clear idea. Okay. So let me repeat myself again. So this GPIO controller is going to have a set of registers where each register has its own functionality. Your RTL code is basically going to configure these registers. One register, for example, one register can be a data register, just simply to store your data. And another register is used to configure whether to perform a write operation or whether to perform a read operation. And another register may be used to just have the interrupt conditions, whether to have the interrupt or whether not to have the interrupt. Okay. So this is why we are going to use our registers, and this is what we are going to have in our practical design also. Is it clear, guys? We will come to how many registers we are going to have in our design and all. Okay. We will see and how we are going to access these registers in our GPIO controller, and how you are going to use your APB interface to access this GPIO interface. That is what we are going to discuss. Is it clear? So just I wanted to give you a clear picture of what is exactly going to have inside your GPIO controller and what is the role of your registers over here. Is it clear, guys? Yes or no? Please let me know. Okay. That's great. That's great. Okay. So that is what written over here. So inside an SoC, we are peripherals are connected through buses. The processor configures the peripherals using register, read or write operation. Okay. Yeah. So why specifically APB for GPU? That is what we have discussed over here. So in AMBA architecture, there are multiple buses. AMBA AHB is for high performance bus. AMBA AXI is for high bandwidth system bus. And AMBA APB is for low power peripheral buses. So GPU belongs to low speed peripheral category. So APB is the most suitable bus. Okay. So yeah, so typical external devices which can be connected to our GPU can be LEDs, push buttons, switches, sensors, or control signals. Okay. So the processor cannot directly connect it to the external pins. It uses a bus interface to access the GPU. And in this design, the GPIO is connected through AMBA APB bus, making it APB slave peripheral. Okay. So yeah, that is what about the architecture. And so the GPU block is going to consist of three main internal modules. So the GPU block, which we have seen over here, right? This is going to have three modules. So first one is APB interface, and second one is port IO interface, and another is interrupt detection. So this is how your GPU interface is going to look like. Where let me show you with some more color. Yeah. So here your RTL code or whatever the processor according to your architecture that will be present, and this will be treated as your master. Okay. And from the master via the bridge or some particular architecture, you're going to get your APB signals. And this GPU module will be APB slave. Okay, this will be responding to the transactions where your processor or the master is going to send. Okay. Now, so we are going to get P clock, P reset, and this is my APB port where all the APB related signals will be given to this APB bus interface. Okay. And if let's say if you don't want to use this APB interface at all, we will have an option which is known as GPIO bypass, where we are not going to use this particular APB interface signals and we can directly connect to our output ports, GPIO output ports. And another is interrupt request, and what is it going to do? We will discuss in great detail. Okay. Now coming to the right hand side, we are going to have one thing is which is known as GPIO underscore enable one underscore N, which is basically active low signal, which is basically active low, and another is GPIO out for sending the data out to my GPIO pins. So here I'm going to have my GPIO pins. So to send the data to output side, I'm going to use this particular thing. And for reading the data from the output pins, I'm going to use GPIO in. Okay. And this is a tri-state buffer we are going to have over here. So if it is active low, we are going to perform the write operation, or if it is active high, we are only going to read the data. Okay, it's a bidirectional bus we are going to have over here. Okay, so this is how your GPIO is going to look like. Is it clear, guys? Any doubts or any queries in this? It's a direct pin. So we can directly access the GPIO pins without using the EPB interface. We have that particular control, but we will face some timing issues if you're not going to if you're going to have a direct control. That is generally recommended if you're going to drive some basic LED control or LCD control, then it is recommended. But if you're trying to access your GPIO pins for establishing a connection like UART connection or some I2C communication, then it's not a recommended option. Okay. Yeah. No, this is the GPIO controller which I'm showing you, which is GPIO module. Yeah, yeah, I will show you. Yes, yes. So basically, this will be present inside your APB bus interface. This is present, right? This particular block diagram, this particular block, those and all will be present. Yes, yes, yes. Yeah, you can say it from bridge or you can directly connect it from, yeah, from some interconnect. Yeah, you can have it. Yes. Others, any other queries? Yes. So shall we move forward? Is it clear? Which particular part you need me to explain, Anusha? I haven't started with the discussion yet. So this is just an architecture. So this is my master, and I've shown right this particular architecture. Okay. So if your RTL or your processor wants to communicate with your GPIO pins, so this is your GPIO controller, which we are going to have, and inside this GPIO controller, we are going to have this particular modules where we are going to have P clock, P reset, and as our inputs, and APB interface we are going to connect it to our APB bus interface, and we are going to have one more GPIO bus. So whatever the RTL code or whatever the processor or whatever the master you are going to have left hand side, right? So that will be connected to this particular GPIO controller. Okay. So from this GPIO port, you are going to drive your output pins. This is your output pins I have shown, right? So this particular thing is going to drive those pins from here, from the right hand side. Okay. Just the architecture I've explained. That's it. Yes, yes. Now is it clear? Yes. And coming to this particular APB bus interface, I'm going to have this particular registers 1, 2, 3, 4, 5, 6. So this registers we are going to implement in our RTL code also. Okay. And the particular meaning of this particular registers also we are going to discuss tomorrow. Okay. So just we are going to have this five registers, and for example, this particular data register, it is going to store the data which is going to be driven, and this direction register is going to decide what should be the direction, and data in is going to decide data in this register is going to store the data which you are going to get it from the output, and set or clear, this is an optional pin. This we will discuss tomorrow. And GPIO interrupt enable is also one of the pin which we are going to discuss, and inter status also, interrupt status. What do you mean by interrupt, and how we are going to discuss about interrupt and all, we will discuss. Okay, first let us try to implement the basic functionality using the basic registers which we are going to have. Okay. Yeah. And these are my APB signals. So P address, P write, PW data, PR data, P select, P enable, and P ready. So you need to be familiar about this particular signals and the APB timing diagrams also, so that you will come to know what is actually happening. Okay. Yes. So this is the operation which is basically happening. So your CPU writes to the GPIO registers. You can also have one RTL code which is present inside between your CPU and the GPIO controller, or else you can directly establish a connection between your CPU and the GPIO controller. Okay. And we are going to use something known as APB interface, which is going to decode the address. What do you mean by address? We will discuss. Okay. And the correct GPIO register is accessible. So after discussing about this address, you will come to know what we are basically accessing it. Okay. And we are going to have port IO interface, that and all we are already discussed in our architecture itself. Okay. Yeah. And interrupt and all, we will start our discussion in our next session. Yes. So that's the basic introduction about your GPIO interface and APB interface, and how you're going to connect your APB and your GPIO and your master. So please let me know if you have any doubts or any other queries you wanted to discuss. Please let me know. And let me open Vivado also, so that I can show you the block diagrams, how I'm going to actually have this connection. Yeah, thank you. So once please wait, I'm opening the software so that I can show you how actually the things are being connected. Let's wait for a few minutes. So meanwhile, you can shoot any questions if you're having. Yes, exactly. So generally, you will have some IP which is known as APB based GPIO. IP is already present in Vivado. You can just drag it and drop it, so you can use it directly. Then why we are learning this? To understand what is actually happening. That's why we are learning it. Let me share my screen. Okay, let me create a project quickly. Okay, I think the board files are missing. Sorry. So in Vivado, we will have an option which is known as IP integrator. So you can just click on create block design and click OK. So your block design will be created over here. Let me open it. So here, first of all, we need to add one Zynq IP so that we will have the processor interface which is present over here. Let me add it. Yeah. So this is what I'm going to have. And let me add GPIO also. It is basically AXI GPIO. Let me show you. So this is my AXI GPIO. Internally, I'm going to can I show this block diagram? Let me show you. I think I cannot elaborate this IP. Okay, this is basically IP, right? So I cannot open it. So here, if you carefully observe, if I want to directly make my processor connected to my GPIO without actually having my APB at all, so I can have it. So I can directly have my connection. So I can click on Run Connection Automation. The tool will only take care of that. Let me press it. Yeah, let me run automation. Okay. So this is how your GPIO is going to look like, where what is that we are going to have is our processor, and this is my interconnect, which I'm going to have, where your interconnect is going to connect your master and your slave, which is nothing but your GPIO. So internally, this AXI interface will be connected to APB interface and it will be converted into a GPIO related signal. See, here we are going to have our GPIO related signals. Okay. So instead of using APB based GPIO, we have an option of directly using AXI GPIO, where internally it is going to have some particular code which is going to convert this AXI related signals into GPIO related signals that we can have. Is it clear, guys? Let me check whether we have something known as APB based GPIO. No, I think we cannot have. We don't have like that. Yeah. No, no, we cannot able to see internally. No, it's an IP, right? Yeah, actually the architecture which we have discussed it, right? So here internally it might happen or it might be using any other different architecture. Yeah. What is the need of it in Vivado where it will be used? What do you ask? What need? Whether you are asking about a GPA, this one, AXA GPA, you're asking about this, right? So this is basically used to control your output pins. So if you are designing like this, then you don't need to write down your RTL code also. So Vivado IPA integrated is a very good feature So if you're going to write this particular, if you're just going to pick and drop the things, and you can generate directly the bit stream. Okay, so you don't need to write down the RTL code also. So it will basically generate you the bit stream whatever whatever it is needed. Okay. Yes. Yeah. So that's about this particular session. So if you have any doubts or any other queries you wanted to discuss, you can stay and have a discussion with me, or else you can leave the session. Okay. Yeah. So if you're listening this for the very first time, or if you don't have any idea about this particular interfacing and all, no, not an issue. Once go through the recording again, and if you're having any other queries, you can have the discussion. Okay. Yes. Thank you. Yeah. Thank you. Good night. Yes, it will be uploaded in the YouTube.